Hello, boys and girls. So we're going to review Standard 1A today. We're going to look at different landforms and look at the constructive and destructive forces, specifically earthquakes, and how earthquakes can be both constructive and destructive. All right, look at the phenomenon. In your notebooks, write 3 things that you notice and 3 things that you wonder. Okay. Today, you're going to look at 6 documents. Each document will give you some information about earthquakes. You are going to take the evidence, the textual evidence that will support whether or not earthquakes are destructive, as well as textual evidence that supports that earthquakes are constructive forces. So I'm going to read document 1. San Andreas Fault. The San Andreas Fault is the most famous fault line in the United States. It runs all the way down the California coastline. It is the place where the North American plate and the Pacific plate meet. The city of San Francisco is on the North American plate. The city of Los Angeles is on the Pacific plate. Right now, the cities are about 400 miles apart. But as the plates move in opposite directions, the cities get closer. Scientists say that one day Los Angeles and San Francisco will be neighbors. This fault line has been the place of many earthquakes. In fact, one of the biggest earthquakes in the United States history happened in San Francisco in 1906. Document 2. Fault scarp is a small step or offset on the ground surface where one side of a fault has moved vertically with respect to the other side. Document 3. Introduction. The sudden shaking of the ground that occurs when masses of rock change position below Earth's surface is called an earthquake. The shifting masses send out shock waves that may be powerful enough to alter the surface, thrusting up cliffs and opening great cracks in the ground. Earthquakes, called tremblers by scientists, occur almost continuously. Fortunately, most of them can be detected only by sensitive instruments called seismographs. Others are felt as small tremors. Some of the rest, however, cause major catastrophes. They produce such tragic and dramatic effects as destroyed cities, broken dams, landslides, giant sea waves called tsunamis, and volcanic eruptions. A very great earthquake usually occurs at least once a year in some part of the world. According to long-term data of the United States Geological Survey, on average, about 10,000 people die each year as a result of earthquakes. Humankind has long been concerned about earthquake hazards. The oldest chronicle comes from the Chinese, as early as the Shang Dynasty, more than 3,000 years ago. Document 4. Effects of earthquakes. Earthquakes often cause dramatic changes at Earth's surface. In addition to the ground movement, other surface effects include change in the flow of groundwater, landslides, and mud flows. Earthquakes can do significant damage to buildings, bridges, pipelines, railways, embankments, dams, and other structures. Underwater earthquakes can cause giant waves called tsunamis. Violent shaking of the seafloor produces waves that spread over the ocean surface in ever-widening circles. In deep water, a tsunami can travel as fast as 500 miles or 800 kilometers per hour. By the time a tsunami reaches shore, it has gained tremendous size and power, reaching heights as great as 100 feet or 30 meters. Tsunamis can be catastrophic, with the potential to wipe out coastal sediments. Continuing with document 4. Earthquakes also can lead to devastating fires. Fire produced the greatest property loss following the 1906 San Francisco earthquake, when 521 blocks in the city center burned uncontrollably for 3 days. Fire also followed the 1928 Tokyo earthquake, causing much damage and hardship for the citizens. Document 5. Earthquakes 101. Earthquakes can cause the ground to shake and crack apart. Earthquakes can be very powerful, and if they occur in or near areas where people live, they can make buildings collapse, bridges sway, and roads buckle. But not all earthquakes are powerful enough to cause damage. In fact, earthquakes are happening all the time on land and in the ocean. Most are small that people don't even feel them. An earthquake is the sudden movement of the Earth's crust. Earthquakes occur along fault lines, cracks in the Earth's crust where tectonic plates meet. They occur where plates are subducting, spreading, slipping, or colliding. As the plates grind together, they get stuck and pressure builds up. Finally, the pressure between the plates is so great that they break loose. Depending on how much pressure has built up, the ground may tremble slightly or shake forcefully. Document 6. The World. April 29, 2015 at 1:30 p.m. by Peter Thompson. It's hard to write about the creative power of earthquakes amid the awful destruction and lost life that we're seeing in Nepal. The human misery and economic damage are front and center in coverage of such tragedies as they should be. But such disasters strikes, it actually helps me anyway, to keep the long view in mind. Along with their awesome destructive power, earthquakes and the slow, inexorable drifting and grinding of the Earth's massive plates that cause them help make our planet what it is: fascinating, diverse, beautiful, habitable. An Earth without earthquakes would be an Earth without dramatic coast of Alaska and the Pacific Northwest, Terra del Fuego, and Kamchatka. An Earth without distinct continents and many of their unique animals, plants, and landscapes. An Earth possibly without even a breathable atmosphere. Plate tectonics through earthquakes and their kin volcanoes release huge amounts of gases into the air, including carbon dioxide, the raw material of photosynthesis, which releases oxygen. Earthquakes churn up minerals from the depths that are vital to life and valuable to humans. They create valleys, lakes, bays, and oceans, diverse habitats for life to thrive and differentiate. And they create mountains. Imagine the earth without the Rockies, the Alps, the Andes, the Himalayas, in which Nepal and its unique culture and spectacular beauty rest. Everest itself, the mountain on which so many died in Saturday's quake caused avalanche, was created by earthquakes. Mighty Everest, the tallest peak on earth, may even be a little taller this week than last, a little more of a challenge to draw humans back. The earthquakes, shifting, cracking, buckling of the Earth's crust that formed and continue to form Everest, Nepal, and the Himalayas are caused by the immense energy of the ongoing collision of the northward drifting Indian subcontinent with Asia, a violent merging of the two land masses that began roughly 50 million years ago and continues at an average of roughly 5 centimeters a year. It proceeds in mostly tiny fits and starts pressure and tension building up in the rocks of the Earth's crust until finally some of it is released. The land shakes, buildings collapse, people die, the Himalayas grow, and India marches north. American scientists say part of India pushes 1 to 10 feet into Asia on Saturday. But that massive slow motion collision does more than build the region's mountains. It's responsible for landforms, ecosystems, and even political geography thousands of miles away. One I happen to know a fair amount about because I wrote a book about it. It's called Russia's Lake Baikal in southern Siberia, 2,000 miles northeast of Nepal. Okay, now you have seen all 6 documents. You are to gather information. You will be able to reread some of this documentation, reread it, so that you can specifically quote from the text information that helps you to know that earthquakes are both constructive and destructive forces, and then you are going to write your claim.